So, hello everybody. My name is Gilles. Welcome for that last session here today. We are very proud to show you the result of our work since more than 1 year, maybe. And it's uncommon for you because for us because we are presenting together. It's uncommon for us to present together, so. So I'm Gilles. I'm working in Paris at Le Furet, which is an insurance comparison website.
I'm Alex, so software architect at Le Furet. It's been 4 years now I work there.
So a few words about Le Furet, and maybe it will help you to understand the rest of the presentation. So we work at Paris for a website. So we develop everything with a small team. We have a big code base with nearly 10 years of code history right now. We push in production every day on our services, providing around 3 million of insurance quote for the French guys, French customers, and we are leading the market in France. Our website is like most of the insurance comparison websites. It starts with a big form. You fill the information to obtain a quote. On the quote is displayed like that. So you have a table with a lot of offers and some button on the right columns to access and subscribe your insurance to the insurer website. So we act like a kind of hub. It's an application that make live querying, live request to the insurer, and so we have some kind of specific pattern which is well documented by many other websites named scattergetter. So scattergetter, it's the fact that you fill a first model that represents your business model with all the information filled in the form by the customer. And after that, we do a kind of input mapping that translates that set of information to dispatch a large amount of requests to each insurer and to obtain a quote. On the response, it's a getter part of the pattern, and we just do the mapping. Try to aggregate the response in the same format and restitute the result to the customer. And we have a lot of business rules in the scatter part. So it's in red on the schema. On that side, every insurer would like to have a kind of filters that to target a specific amount of customer, like you are young, you are maybe you have a risky profile, and other stuff like that. For our business in France, at that time we have more than 17 partners, so you could imagine the amount of business rules we have to implement in our system. And we need to maintain on having a decent governance in that area. Before we start to work on the topic, we use a kind of very basic way to implement the governance of the business rules. Each business rules was implemented in a small class with there is a kind of naming convention with self-explained by the name of the class that try to represent what is the business logic inside the class. So it looks like that. So it's plain Java with a kind of null safety before implementing the rule, and then you have a lot of very large set of statical method, helper class, everything you like to mutualize your code. Something like a helper class to transform date. And the pattern is using an exception, is based on exception. So if the rules match the parameters and you would like to drop the profile, you throw an exception, sorry. And here is what we expect with our new framework. So the business rule, it's more or less, oops, sorry. Yep, more or less is the same pattern, but we have the business rule written with a one-liner. All the logic is nearly as you could explain it in a business language, and the goal of the reworking everything in that area is to provide compliance, auditability, so especially for business people in the company, for legal people in the company, and for the governance and the clarity is much more oriented on the development team, which has some heavy problems to maintain on having a good policy to maintain that set of rules. So now we will switch to the IDE, and we will try to see how we could implement that live. So first, we use a small Java model, which is so here is some code that you could find on our GitHub in the project. So a small model with annotation. So it's based on a user, an account. All the annotation are just available on each field. We use an ID, a key on in each annotation. You have also a readable part, which you will see just after use for the generation. On each readable is supported in a resource bundle, so you have translation and internationalization available for each field. After that, we generate during the build process of the project, we generate a class named this DSL sample model. So it's a companion class that is generated by the framework. And you could see here a lot of DSL route that will help us just after to write our natural language business rules.
Yeah, just to make sure, here you have an annotation with like a key on a field login, and when you code generate, it generates that class here, and you can see for each key you have one field in the generated DSL. So that's your entry point for your DSL.
So let's go to rewrite the rules that we saw before, and you will see in the IDE of Alex.
Yeah, so we're going to rewrite that rule. So there are like 4 conditions. The user needs to have more than 18 years old. His email needs to be smaller than that other object configuration max email size. He needs to live in France, and his phone number needs to start with 33. So that's a validation rule, so we're going to code it here. So we're going to have a sample model rule. I can import that. We're going to call it account rule. And then your entry point is the DSL you've generated, right? It contains your entry points to your fields. So the first one was 18 years old, right? So I'm going to use user birth date like this. And then this is a date field, and on date field you have date functions. So if you see here, you have age at, you have after, before, etc. So those are dates, date functions. And if you check on the parameter, is going to be taking only dates. So date supplier, dates, or another field that has type date. So I'm going to use age at here. I'm going to use a local date supplier here. So why am I using a supplier and not the actual date? It's because we're just constructing the rule right now. So by the time it gets executed, maybe it's later. So if you use a static time, it's not going to work. Like that code is not going to work tomorrow. Okay. And age at is a condition that returns it's a integer conditions. And on integer condition, you have integer operations. So now you have greater than, lesser than, between, that takes integer too. So everything is strongly typed. So you cannot like compare different types. The compiler is actually going to tell you. The DSL is made so that the compiler tells you you cannot do that, right? I can do static imports here. And if I want the code to compile, I'm just calling the validate method. This is the terminal method that returns a sample model rule. So I can chain stuff. So I'm just doing and. You can do or, for example. And then I'm continuing to write my rules. So the next one was email length. So account email. So this is a string type. So I have length. You have starts with matches, etc. So length, and then I can type lesser or equals. And then I'm taking the configuration max email size. So here we're comparing one field length to another field, right? Then finishing the condition. So it's account country equals country.fr, and then account phone number starts with +23. So we have a rule. That's nice. Let's see if it works. So we're going to do a test. You want to continue, maybe?
Yeah, so I will continue to explain. So for that test, we will simply set up our sample model, so instantiate it. And we pre-written a full setup in plain old Java, so we'll show you just. So we could take a look how it's set up. So we have a user. We filled all the fields by hand, as we can do as your first cup of Java. And after that, we could use the rule and try to execute it. So executing the rule is very simple because during the code generation phase, we generate a strongly typed API that take as parameter exactly the instance of your model. And we provide a set of assertion for assert_g that allows to write also in a Fluent fashion your assertion based on the rule. here we go.
So I'm executing the test. I've added a print here, so the test passed. So it means that our model is valid for that rule. And here you can see that I'm calling the rule, and on the rule I'm calling the readable method. So what does that do? Is that it takes the rule, it constructs a syntax tree that we're going to see later, and with that it generates a human readable format of the rule. So here we can see this is the field we have our rule on, this is the operator, and this is the rest of the rule, and then you have the whole rule tree printed in human format, okay, from only the static part.
So now maybe it's time to make the rule failed. So to do that, we will just duplicate the rule, and we will introduce a wrong value in the model, for instance, a phone number. So suppose we are in Denmark. The phone number is starting with 45. And yes, it failed. It failed, but what the test assertion is saying is that it tells you that it's a wrong phone number. So in fact, the message is really interesting because it gives you the reason why it failed. So we could assert that. So it failed on the failure cause is the phone number. So the framework has the ability, in fact, to have a kind of self-explanation saying the right reason why there is a failure.
Okay, so back to the slides. So I talked a bit about it. So the syntax tree is constructed as soon as you instantiate your rule. Okay, so this is the rule we've written during the live code. So what you see, it's a binary tree of predicates. So every node is a predicate. So if you look here on the left side, you have user, birth date, age, etc. The whole node is a predicate, so it evaluates to true or false. And inside you have a succession of different lambdas, so functions that are going to be executed one after the other. So user birth date, it goes into the context. Well, the field takes the value, age is a function that calculates an age, etc., etc. It's going to evaluate from bottom down and then go up and end, go down and evaluate the account email length, etc., etc. So basically what you have is each node you have predicate true or false, and you have the root predicate which evaluates to true or false also, and that gives you if your model passes the test or not. So why do we do a syntax tree? Well, Gilles talked about auditability and governance. We want to be able to have a rule catalog without needing to look at the code. So what we do is that from the static definition, we generate that kind of catalog, and we can show that to non-technical people without looking at the code. And we know that there's a direct match between the catalog we have and the actual rule we've implemented, right? So this is the example sample we have in dOOv with a sample of the rules. Yeah, there's multiple formats that we've already implemented. What you see here is text. We have markdown. We also have HTML already implemented. So the syntax tree is internationalized via message bundle, as you saw in the live demo. So I'm going to do a quick demo of our rule catalog. So what we do at Lifure is that we have 500 rules, like we told you before. So this is our production environment. So you can see that you have a small rule here, you have a bigger one here, etc., etc. I'm going to put that in English so you can see a bit better. We haven't translated our domain models, so this is still in French, but the operators are in English. So what you see here is a HTML representation of the actual syntax tree. On the root, you have a match all, which is a big AND, right, with 6 different conditions. They are numbered here, and then some of them are nested, so you have OR inside the number 4, number 5, and number 6 with 2 different conditions. Those are tokenized, so the first part here is the field. The middle part here in bold, it's the operator, and then on the right, is the value it's comparing to. So it can be a field or a fixed value, right? So what is interesting with that is just statically, without executing anything, we have our whole catalog, and we can say, well, we want to know for that field every single rule that actually applies to that field. So we've just implemented a small web app that does that, and by clicking on it, I can see all the conditions all the rules that apply to that specific field. So there are some for this one. So going back to the other page. So this is all like the static part of the abstract syntax tree. But what we also do is that we capture the value during runtime. Okay, so we have our user profile that fills the form, and then we apply the filters on them. So every time we do that, we count if the filter fails or not. Okay, so this is a runtime and dynamic part of the abstract syntax tree. What we do with it is that we make stats. So here we see that 60% of our traffic were filtered by that rule. Okay, this one. What is also interesting is that we can separate that by the different nodes of the tree. So here you can actually drill down in the different nodes and see what is the ratio of the people that were filtered by that part of the tree. Why is that interesting? It's because this enables us to drive our business. Okay, so this is the traffic we're sending to the insurer. Okay, so if we remove rules, they're gonna have more traffic, and if we add rules, they're gonna have less traffic. So if an insurer says, well, we don't have enough traffic, we would like to have more profiles, we can just come here and then see, well, this rule filters a lot of person, or that one, or the whole thing, or another one, and we can just say, well, we can know approximately if we remove that, how much more traffic you're going to get. Okay, so this enables us to drive our business on a live system.
And just to make a short precision, what you have in the open source framework is the ability to write that part on here. So all the rendering, HTML rendering, is available open source. On the top part that selects the insurance product is something we developed for our website. So.
Okay, back to the slides. So there was the rules catalog and the execution statistics. This is all in the open source dOOv framework. I'm going to talk a bit about the failure cause. So here you have a rule which is written in English up there. We've written it in dOOv. It's not very well written, as you can see, because there's a repetition on the country equals France. Why we're showing that is just because it has no impact actually on the engine. It's going to execute anyway, so you can write your rules pretty much as they come. What is interesting is that the failure cause will be simplified for you, so it helps you having a simplified version of the failure cause, but not necessarily the original rule. So if we take a model that we instantiate, so we're using an email, a country, and a birth date on the model. So on that rule, in green, those are the nodes that the predicate evaluates to true, and in red, the predicate evaluates to false. So if you ask dOOv to execute the rule here on the model, and you call get failure cause, you're going to have a count for number starts with +33. So how do we do that? It's like a big AND, and we can simplify that failure cause to its minimal state, just because it's a big AND and only that node fails. Okay. We can show another example. So here it's showing you another syntax that you haven't seen. So match any and match all. So match any is a big AND and match any is a big OR and match all is a big AND. So you have a OR, so you have two conditions with 3 ANDs in there. So you can. So here, if you instantiate your model and you only put a birth date and a country, those are the nodes that are going to fail. So here, the phone number is not good, and if you take the other end here, the country is not good and the phone number is not good. So how do we simplify that? Well, because it's a match any, so it's a OR, it means that if you want to simplify either that term up there or this term here, it needs to all pass, all right? But there's a failure in each of them, so you're keeping both nodes. But the one up there is match all, and only one element fails, so you can simplify that. So here you read match any and only the node that fails. And down there, finally, you have a big AND. There's 2 nodes that fails, so that's what dOOv shows you. Okay, so we're simplifying to the smallest failure cause we can find. There's something in pretty much all languages when you're doing bowling logic, which is called short-circuit. So what that means is basically if you already know that a boolean predicate is false, you don't have to necessarily execute all the nodes in the tree. So in Java, if you have AND, so predicate 1 and predicate 2, if predicate 1 is false, you don't have to execute predicate 2, right? You don't have to actually know its value. You can just short circuit, right? And say, well, your AND is false. Okay, so this is basically Boolean logic in any language. It's actually also implemented in the Java lambdas, which is pretty nice. The problem we have with that is in dOOv, if we want to have the whole failure cause and we want to know exactly which node of the tree invalidated, we need to execute all the tree. So we actually have to deactivate short circuit for that. It's going to be slower, but it also means that we can have exactly why the rule failed for the whole tree. So here you see that rule that with short circuit false, so we've deactivated that. Why did we do that? It's because here it's an AND, this one, okay, this part. Do you see my cursor? Yeah, you do. This part is an AND. On the second one, it fails. So if you're short-circuiting, it means that the last one is not going to get executed, okay? So you're not going to have the full failure cause. You're not going to see that account phone number starts with +1. It fails too. Okay, it's going to be different for that example. So we don't especially need performance on that part of the application. So we can disable short circuit, and it enables us to have those percentage right. Okay. So the title of the presentation is Beyond BeanValidation, and we haven't talked about it yet. It's because, well, first let's talk about performance. So we've did a small micro benchmark. We just wanted to compare, like, for one part of the rule, how does it compare to bare metal Java? So in dOOv, everything is a lambda, so everything is a function, so every node in your tree is a function. So what we did, we compared like bare metal Java to one node in the tree of dOOv, so it's the same ballpark. It's a bit slower in dOOv, so it's probably the overhead of the lambda. But you can see that it's pretty close. So what you need to look at is the mean here. The throughput is a bit higher for bare metal Java. And then how does it compare with other validation frameworks? So we've done a small app just for fun. So this is a benchmark. It pretty much executes the rule we've live coded now. So the blue line is bare metal Java. So you see it's actually faster than us. We are in red, and then in green down there is BeanValidation, the Hibernate implementation 607, which is the very latest one, which is a lot slower than us. The reason is pretty simple, is because BeanValidation are using reflection to go and fetch the field value. We code generate that part. So it's actually very, very fast in dOOv to go fetch the value, even if it goes through a lambda. The code generation for the get and the set is also code generated. Okay. So in BeanValidation, how does it work? Well, you have annotations that you put on your fields, and it somehow validates your model. But in BeanValidation, it's not strongly typed. Okay, in dOOv, we're strongly typed, so this code does not compile. The annotation email validates that it has a format that corresponds to an email, but it only works on strings. Okay, so this is going to be caught by the annotation processor, but because it's pretty far in the compilation process, you might actually not see it in your IDE. Okay, so this should be string for it to work. So BeanValidation is not strongly typed. It's hard in BeanValidation to do complex, well, what we call cross validation, so between two fields. So here we would like to test that a phone number starts with +33 only if the country is France, okay, for example. In BeanValidation, to do that, you need to write a custom validator. The syntax is quite quirky, but you cannot do it right there. In BeanValidation, you don't have natural language because there's no resulting DSL, there's no resulting syntax tree, sorry. That can generate the actual content of the rule. So there are many things that can go wrong. So here you can write a message to explain what the validation is doing, but then because it's not the actual rule, it can change and not the actual rule, so it can be false. If you take dOOv, then it's the same thing we've written here, so it validates that the length is between 10 and 200, and it generates for you the readable, the natural language string. And you know in dOOv that it's always going to be, the code is always going to be in phase with your readable or your documentation because it's generated from the code. So some differences between BeanValidation and dOOv, it actually doesn't serve for the same purpose. So in BeanValidation, you want to allow syntax validation. So it's more like surface validation of your domain model. In dOOv, we do consistency check. So you take your whole model and you have real business rules, and you want to implement that in a business way. In BeanValidation, rules are written on the model. In dOOv, rules are written outside of the model, and that enables you to write complex checks. If you imagine our 500 rules all written on our model, it wouldn't be maintainable, right? So we need a way to write it outside our domain model. Finally, BeanValidation uses reflection. And we use code generation, so this is the main difference in terms of performance between BeanValidation dOOv. Okay, so to conclude, what we've achieved is that we've migrated our 500 rules to dOOv. So this is in production for it's been 6 months or something. Yeah. And what we've achieved is actually a bit more than we've planned in the beginning. Well, we have compliance, auditability, and governance, and all that business rule catalog and statistics elements. We realized it was very, very, very useful for driving our business on a day-to-day basis. So mission accomplished with dOOv and our business rules. We've just released dOOv 2.0. We consider it very stable, so we're our own user of the library. We've added Gradle support, so the code generation can be done with Maven or Gradle now. We have better handling of failure cause, new operators. We have pretty good documentation and a new wiki on our GitHub. And we have beta support for something we call Doom. So what is Doom? So it's in beta right now. We're kind of using it in production, but it's not all there yet. It's a object-to-object mapping framework. So it stands for Domain Object-Oriented Mapping, so Doom. It features the same AST to text and statistics functionality than dOOv. So this is the syntax. So you see the same elements. So user email is a field that you can map to another object. So user email to another domain model called insurer email. And you can see that we actually use dOOv here for some predicates. So here the test is a condition that comes from dOOv. So stay tuned for the next version. It's going to come at some point. So we have a website, dOOv.io, with frameworks and example. The code is in Maven Central. It's version 2.0. Those slides are on the GitHub. It's Apache license, so if you want to try and contribute, you can do that anytime. Thank you very much. On n'a pas sauté.
Si, c'est pour ça que j'ai paniqué. Yeah, it's exactly what we have done for the benchmark, because we are running on the same model, so we don't present the code, but we are running on the same model, bare metal rules, dOOv rules, and BeanValidation. Maybe you could just show how mix the annotation on the email, maybe.
This is
on the account, I think. No, the email is on the account. No, it's on the user.
Well, you have an example here. So that's BeanValidation.
Not null is BeanValidation annotation, and we have also the dOOv annotation that is used after by the framework. First for code generation. Yeah. You could mix together. And the good news also is that the migration path is very incremental, because you have the ability to just push a few annotations in parallel of your existing annotation set on your Java beans. And after that, you have a new resource that is companion class, and you could start to write rules, migrate it in an iteration fashion. And that's what we have done. In fact, first I present, we had our business logic was written each one rule per class, and in fact we just take the content of each class and rewrite with dOOv. And after 2 months, everything was migrated. At the end, we simplify the pattern, but during the migration phase, we just rewrite the existing Java code with dOOv code, and after that, we change the pattern to be much more simple. So yeah, it works very well to as a migration path, and the benefits is that when you express your business logic and your validation just outside of your domain model, yeah, you gain the governance very easily. Governance of a large set of BeanValidation is something not a bit scary. Any other question?
Thank you.